5.1 Adding Subtracting Polynomials. So first we're gonna try to look at some terminologies of polynomials. Okay? Polynomials is basically contain variables, coefficients, operations such as add, subtract, multiply, and most importantly, a polynomial must have non-negative integer exponent, meaning it must be a positive integer exponent. So for example 1, okay, let's say this is example 1, the term is basically separated by plus or minus sign. So for example 1, there are 4 terms, which is negative 2x to the 4th is one term, and 3.4 x to the second is another term, and negative 5 over 6x is another term, and lastly negative 7 is another term. So there is a total of 4 terms. The leading term is basically, if you write the polynomial in descending power, the leading term is the very first term, which is the one has the highest exponent. So in this case, the leading term is negative 2x to the 4th power. So first you have to write it into descending power first. Okay. The constant term is the term that does not have variable, so it will be the last one, which is negative 7. The coefficients are basically the numerical factors that associate with the variable in each term. So in the first term, the coefficient will be negative 2. In the second term, the coefficient will be 3.4. The third term, the coefficient will be negative 5 over 6. And the last term is a constant term, so that's a coefficient. The leading coefficient is basically the coefficient that go along the coefficient that is in the leading term. So in this case, the leading coefficient is negative 2. Degree of a term is basically talking about the power of the term. So if it is a single variable like in example 1 that we are talking about, the degree of a term is very simple. Degree of the first term will be 4. Okay, so this will be 4 is the degree of first term. And degree of the second term will be 2 because the variable has exponent 2. So this is for the second term. The degree is 2. And the degree of the third term is 1 because the variable has exponent what? 1. And if there is no variables on it, you can say that's 0 degree. That's your last term. Okay. And so the degree of a polynomial is basically the highest degree among the degree of the term. So in this case, the degree of a polynomial will be 4, for example 1. We have uh, we have a few terminology for the polynomial depending on how many terms you have. Okay, a monomial is the polynomial that only have one term, which is it could be 3x, or it could be 1/4 x to the 5th power. So notice that it's only one term, so everything's multiplication. Binomial has two terms, which is x plus 2. That's a binomial. Or it could be 3x squared minus 5. That's a binomial. Okay, two terms. Remember, the terms are separated by plus or minus sign. Trinomial is 3 terms. The polynomial that has 3 terms. So in general, the famous one that we're going to look at later on is this trinomial, ax squared plus bx plus c. Okay, or it could be another trinomial, x to the 7th power minus 4x minus 2 or plus 2. Okay, so those are the trinomials. So now, adding, subtracting polynomials are like combining like terms. Hopefully we remember like term means what? It have to be same variable. Okay, it must be same variables, and it must have what? The same exponents on each variable, right? Same exponents. So to do the first problem, perform indicated operations. In this case will be what? A trinomial adding with another trinomial and then taking away another trinomial. So first step will be taking out the parentheses as usual. So it will be 5.4t to the third power minus 3.2t to the second power plus 2.1t plus, because of a positive, the second trinomial, you can just drop out the parentheses, which is going to be 4.3t to the third power plus 2.1t to the second power plus 3.2, and distributing the negative sign to the last trinomial, then it will become plus 7.6t to the third power minus 8.7t to the second power minus 9.8. Oh, it should be plus 9.8t because when you distribute the negative. Now, what we're going to do is we're going to combine like terms on all of these. You can use calculator to make it fast on adding and subtracting. So first I have t to the third, t to the third, t to the third. Notice that I underline the sign in front of it so that I can clearly see what operation I need to do. So that gives us 5.4 adding with 4.3 adding with 7.6, that gives us 17.3t to the third power. Now continue on the next term, t to the second, t to the second, t to the second. So in this case, I will be talking about negative 3.2 adding with 2.1 and minus 8.7. So this gives us negative 9.8 t to the second power. And last, next up will be t term, and then t term right here. So 2.1 plus 9.8, that will give me plus 11.9 t. And lastly, which is the number itself, plus 3.2. And that will be my final answer for adding, subtracting polynomials. So use a calculator, that will be a lot faster. The next problem. So this is more of like reviewing for you on order of operations. So when I simplify adding and subtracting this polynomial, we're gonna go order of operation, which is inside the bracket, distributing negative sign first. That will be minus 3p plus 6 minus, on the next bracket, it will be 5p. Distributing that negative sign will be minus 8 plus 9p squared minus 4p. Now you can continue this distributing. There are dropped out the bracket, so it'll be 2p squared minus 3p plus 6. Distributing the negative, it will be minus 5p plus 8 minus 9p squared plus 4p. Now combine like terms, which is in this case 2p squared and a negative 9p squared. That will give me minus 7p squared. And then the p terms, right? Negative 3p minus 5p and then plus 4p, which will give me negative 4p. And lastly will be the number 6, 8, which is going to be plus 14, and that is my final answer. Example 2 is basically recalling for translation. So subtracting the first polynomial from the second polynomial. So first thing that you need to do is write it out the problems correctly, which is 2x squared minus 3x squared y plus y plus x squared minus 2y, subtracting the first polynomial, which is, you can simplify a little bit right here before you even continuing to make it easier, which is that will be 4x squared y minus 2x squared minus 3y. So notice that it's much easier. So you're subtracting the first polynomial from the second polynomial. So now, continuing this, like as usual that we do, take it out the bracket and in parentheses, that will give me 2x squared minus 3x squared y plus y plus x squared minus 2y. Distributing the negative sign right here, it will be minus 4x squared y plus 2x squared minus 3y. And then combining like terms, in this case, which is 2x squared and then 2x squared, that will give me 4. Oh, right here I have missed 1, so it should be a total of 5x squared, right? So 5x squared. And then the next one will be the multivariable case, negative 3x squared y and then negative 4x squared y. So that will be minus 7x squared y. And lastly will be the y term, and a y term. So it will be negative 5, so it will be 4y. That will be my final answer. Now we're going to look at evaluating the polynomial functions. So recalling a little bit on functions, and then we're going to learn a new notations, which is two function adding, two function subtracting cases. So let's say first example is asking you to find f of negative 5. So that means I want to evaluate at when the input is negative 5. So 3 times input squared plus 2 times input minus 15. Remember, this is how I taught you to write it out. And then plug it in where your input is, negative 5, negative 5. So that gives us negative 5 squared is 25. 25 times 3 is 75 minus 10 minus 15, which will become equal to 50. That is my final answer for this first one. And the second part is asking you to find f of 0, evaluating at 0. So 3 times input square plus 2 times input minus 15. So in this case, my input is 0. So I got my result, which is the final answer will be 0 plus 0 plus minus 15, which is negative 15 is my final answer. So adding, subtracting polynomial function, this notation you have to remember, this is the equivalent. When you say f plus g of x, that means function f evaluating at x plus the function g evaluating at x. So meaning you are evaluating two different functions with the same input value, and you are adding the function values together. Similarly for subtraction. So we're going to use these equivalent formula to do the next example. So example 4. So given to you f function, g function, and h function. First question is asking you to find f plus g of h. Oh, f plus h of x. So that basically means f function evaluating at x plus h function evaluating at x. I want you to write this step down, so that way you will remember the notations. Okay. Once again, f plus g of x is not distributive property, not distributive property. This is a function notation. This is not multiplication. Okay. It is not distributive property. So you need to remember that a function notation. So now we substitute what is f functions represent. F function is represented by the formula 2x squared minus 4x plus 3. And an h function is represented by negative 4x squared plus 5x. Oh, my bad. I copied it wrong. Negative 4x plus 5x squared minus 1. So now it just become adding two polynomials now. So like before, we're going to drop the brackets. So this will become minus 4x plus 5x squared minus 1. And finally, combining like term, that give me 7x squared minus 8x plus 2 is my final answer. Moving on to the next example. The next example asks you to find h minus g of x. So that basically means h function evaluating at x subtracting g function evaluating at x. So far, both of these example is in general format because our input is what? X. So now h function, that is basically negative 4x plus 5x squared minus 1. My g function minus g of x is negative x squared minus 2x minus 6. So it's very important that you write it with the brackets right here, because that's how you will remember to distribute this negative sign to the second polynomial. Okay. So now distributing this negative, right? Taking out the brackets, that will become negative 4x plus 5x squared minus 1 plus x squared plus 2x plus 6. So combining like term, that give us 6x squared minus 2x plus 5 is my final answer. And lastly, we are evaluating at a particular input value. So this basically means f evaluating at 1 plus g evaluating at 1 minus h evaluating at 1. So what we're going to do is we're going to find out on the side what is f of 1 equivalent to. What is g of 1 equivalent to evaluating? What is h of 1 equivalent to when we evaluate it? So plug it into the f function. So let's go back and then look at f functions. That is what? 2x squared minus 4x plus 3. So that will be 2 times input square, right? Minus 4 times input plus 3. So that's f function. And my g function is negative input square minus 2 times input minus 6. My h function is negative 4 times input plus 5 times input square minus 1. So we want to evaluate all of this. So I'm going to first substitute into f functions my input 1. So that gives us 1 squared is 1, so it'll be 2 minus 4 plus 3, which my answer is 1. So I got the value of f of 1 is 1, plus what about the value of g of 1? So substitute into g functions 1, 1, right? And this gives me 1 squared is 1, so it will be negative 1 minus 2 minus 6, which give us negative 9. So I got my g of 1 is negative 9 minus, now lastly, h function. So substituting 1, the input 1 into h. So this gives us negative 4 plus 5 minus 1, which is equal to 0. 0. So I have 1 plus negative 9, that will be negative 8 is my final answer, and this concludes the section.